lines L1 and L2 have equations r is equal to 3, 4, negative 1 plus lambda 1, 0, 2, and r is 3, 10, 2 plus mu 3, negative 2, 5, respectively. Plane pi1 contains L1 and L2, and plane pi2 has equation x minus 2y plus 2z equals 2. Determine a vector that is perpendicular to plane 1. Well, plane 1 contains both of these lines, so it's going to be perpendicular to these two vectors. That means that we could do a vector product. So 1, 0, 2, 3, negative 2, 5. Covering up I gives us 0 times 5, which is 0. Take away negative 2 times 2. So take away negative 4 gives us positive 4. Covering up I, so what I'm talking about is doing that, gives us 5. Take away 3 times 2, which is 6. So 5 take away 6 is negative 1. For the middle one, that we change the sign, so that one just becomes 1. And I may as well just do the K1. And then we get negative 2 takes 0, so that is negative 2. Show that an equation for the plane is 4x plus y minus 2z is 18. Well, we know that r dot n equals a dot n. So we've got r dot 4, 1, negative 2, since we now know that's the normal, is equal to, just choose one of the points that's on the plane. So I'm going to choose this one from this line. 3, 4, negative 1 dot 4, 1, negative 2 gives us r dot 4, 1, negative 2 is equal to 12 plus 4 plus 2, which is 18. And so in Cartesian form, that's 4x plus y minus 2z is equal to 18. Determine a vector equation of the line of intersection of pi1 and pi2. So our pi1 is this one. Pi2 is the x minus 2y plus 2z is equal to 2 that we were given at the beginning. And so the two planes must intersect somewhere, and then you would have a line of intersection. That line of intersection must be perpendicular to the normals of both planes. So we're going to do another vector product. 4, 1, negative 2 being the normal for the first plane. 1, negative 2, 2 being this one. And same thing again, covering up the i's gives us 2, take away 4, negative 2. Covering up the j's gives us 8, take away negative 2, so that would be 10, but we take the negative on that one. And then covering up the k's would give me negative 8, take away 1, negative 9. So I'm actually going to just not use those negatives and use 2, 10, 9. So that would be the direction of the line. And then we just need a common point. If we take y equal to 0, here and here, we get 4x minus 2z equals 18. And we get x plus 2z equals 2. Adding those gives us 5x equals 20, and so x equals 4. So 4. We took y as 0, and if x is 4, substituting back here would give me that z is negative 1. So that point is on both planes and therefore on the line of intersection. And so our line is going to be 4, 0, negative 1 plus lambda 2, 10, 9.